This will be a follow-up video on what I did in the previous video. This will be part 2. So we're dealing with normal distribution and probability. Last time we used the standard normal curve. I laid down the foundation for the computation of probabilities for data that are normally distributed. And obviously we'll have this type of graph. We talked about probability here, the definition, and how to find the z-values and so forth. This is your standard normal curve where the mean is at 0. Standard deviation for a standard curve is always 1. And these, of course, would be the z-values that you would use either in a table, using a table. I also use the calculator to compute some of these basic probabilities. In this case, we'll go a little bit further than this. I'm going to pose one example here that you can read and see if you can compute it. It's very similar to the one that I did in the previous video. So I'll let you read the problem here. You can pause the video and then try this on your own using the techniques from last time, or maybe some of the ideas from this video will help you. So we want to find the number of scores falling into each of the following intervals. So we have 300 math students take a math exam, and the distribution of scores can be treated as normal. So that means we can use this type of procedure. Find the number of scores falling into each of the following intervals, okay, within one standard deviation of the mean. Okay, so we look at the table over here. This is one standard deviation between -1 and 1, which is, of course, percent 68.26. Probability would be 0.6826, and so on. And within 2 standard deviations of the mean. Again, you can use the graph, or you can use the calculator to find the percent. You want number here, so once you get your percent, you simply multiply it by 300, and that'll give you the number of scores in the interval within 1 standard deviation of the mean. The same thing with part B. Okay, so for example 2, I'm still going to use the calculator. So it says in one area the average motorist drives about 1,200 miles per month. Okay, so that's your mean with a standard deviation of 150. Okay, so you got your mean, you got your standard deviation. Okay, so we could convert those to z-values, or we can plug them in directly into the calculator. And I'll show you that in a little bit. Assume the number of miles is closely approximated by a normal curve, okay? And find the percent of all motorists driving the following distances. So in this case, you want percent. Okay, in some cases, if they give you the number of motorists, they might want the actual number of motorists, or they might want the probability. Depends. Okay, so for part A, we want the percent of those that drove between 1,200 and 1,600 miles. Okay, so I'm using the TI-84 plus Silver Edition virtual calculator. So then I hit the second key, and I want here in VARS variables, that gives me distribution. So what number 2, cumulative distribution function. So I hit 2, and then I clear this, enter the value. Okay, so between 1,200 and 1,600, so the lower bound is 1,200. So I enter 1,200. And I come down, and then the upper bound is 1,600. So I enter 1,600. And then for this one, mu is the average for the mean, which of course is 1,200. Okay, so I already have it there, 1,200. And then remember, if you're dealing with the standard normal curve, then the mu would be, this would be 0 here, and the standard deviation would be 1. Okay, that's if you're entering the lower and the upper bounds as z-values, but here I'm not using the actual z-values. Remember, those, to get the z-values, you have to subtract the mean and then divide by the standard deviation, and then this would be 0, and the standard deviation will always be 1 for that type of setup. Okay, so then I come down and paste this. Standard deviation in this case is 150. We're not dealing with a standard normal curve because of the entries that I put in there. So I hit enter and then enter again, and there we have it. The probability would be 0.4961 and so on, round off accordingly. But in this case, you want the percent. So I would round this off. I'll bring this over here. So it'll be 49.62%, or I could round that off to 49.6. So 49.6%. That would be your answer. Okay. Now let's clear this, and let's go again to this screen here. So I'm hitting the second key and then VIRS. I'm in accessing the distribution menu. Okay, so I hit number 2 again. I want the CDF function. And so now for B, it's between 100 and 1500. Okay, so I'm just gonna, instead of clearing that, I'm just gonna type over it 100, or 1000 rather. And 1500. And then the average again is 1200, so I just leave it the way it is there. Standard deviation is 150. Leave it the way it is. Go down to paste. Hit enter again. And there it is, 0.8860. That represents probability, but again, it also represents percent, which is with a decimal over 2 places. And then add your percent sign, and then round off accordingly. So in this case, I'm going to round out to one decimal place. If I move this over 2 places, that becomes 88.6%. 88.6%. And that would be the answer for that one. Okay, so we clear this. Now on the next one, again, it reads, find the percent of motorists driving the following. Okay, so more than 1,300 miles. More than 1,300 miles. Okay, so again, access that same menu. Second here, VARS, accessing distribution, and I want number 2 again. Okay, so now more than 1,300. Okay, so 1,300 and then everything to the right. So the lower bound will be 1,300. So I just say 1, 3, 0, 0. Okay. And then upper bound would actually be infinity because it's more than 1,300. So if you look at the normal standard curve, it's everything to the right of that 1,300. Okay. So you can see that the curve drops, never touches the horizontal line, the baseline, goes on forever. So for the upper bound, we want to put in a large number that goes all the way to the right. So you can put 50,000, something that's real large, because it's infinite really, so you can put it, anything, a million. I'm going to put, see what I get here with 55,000. Okay, and then, so you don't want to enter something like 1340, okay, or something like that. You want to have something very, very large to the right. Okay, the mean is 1200. Standard deviation in this case, like I said, is 150. And then I hit enter. Oops. Gotta paste this here, so come down, paste, then hit enter again. And there it is, 0.2524. So that's the probability. So they went percent. So just move this over twice, and let's round up to one place. So the answer to C would be percent of drivers driving in that interval would be 25.2. 25.2%. Okay. We clear this. Now, less than 1400. Okay, so this is going to go pretty much the same way, except it's not. Now we're going to the other side. So second, and this function again, number 2. Okay, so now in this case, we're going to the left of 1400. So we go, this one is going to be 1400, upper bound. And then the lower bound, okay, that's on the left, to the left of everything, right? So it should be negative. So we're just going to pick negative. And then again, I'm just going to pick negative 55,000. You could pick other values and it would work fine as long as it's large enough to get your way back out there. Okay. And then we go down. Again, everything else stays the same. The mean is still 1200. Standard deviation is still 150, and then I'm going to paste it. Again, I just remind you that if you were using z-values for the lower and the upper bound, then the mu would always be, or the mean would always be 0. The standard deviation would always be 1. Okay, but in this case, I'm letting the calculator compute that for me. So I hit enter. Okay, and then enter again to do the final computation. And then you have it. The probability, if they want that, is 0.9087 and so forth. You round it off. They want percent. Move the decimal over 2 places, put your percent sign and round off. I'm just going to round it up to 1 decimal place. So this would be 90.9. 90.9%. Okay. Now, if they wanted the actual number of drivers in that particular category and they gave you the number of drivers, then all you had to do was multiply the percent as a decimal, which is, I would just leave it this way and then multiply it by the number. So in this case, just 90.9%. Okay. And that completes this video. Thanks for watching. You have suggestions in any other type of math videos you want to see, just put a comment at the end of the description and I would consider those. Again, we'll see you next time.